there for right now. Change in y value divided by change in x value. Okay, well, since we're talking about functions, we can simply transcribe this and say change in output, f of x, g of x, q of x, over change in input, x value. Okay, so if you see the definition on the top of page 147, this is what they have. This is what you've learned. Same exact thinking process. You simply have to think of your output value as the same thing as your y value. Okay? Now the scary thing is though, and this irritates me, is that they will, the way they write it sometimes it looks a little bit tricky. And I particularly struggle with how example 1 looks because it takes me a while to kind of think about it. So I'm going to try and go through that with you and show you some examples. So this is going to be example 1 from my world. Finding equations of the linear functions, the f function, f function, given the following data, and g function. I'm going to give you some data and we're going to use it to uncover the information that we need. Okay? Trying to decide which one I want to do first here. Okay. We'll do okay. A pair of points. All right. Here's the f function. The f value when you input a 3 is 12. The f value when you input a 5 is -2. To translate that into x's and y's, it would look like this. Okay, to translate it to x's and y's, it looks like that. Okay, so this is like saying the result of x being 3 is 12. This is like saying the result of x being put in as 5 is -2. Once you get these translated over to here, you can do a lot of different things. Starting with creating a linear function using that data. And you will use that, I promise you, in your upper level math. First thing you're going to want to do is see if you can find slope. If you're given 2 pairs of points, and isn't that what I translated them into? 3, 12, 5, -2. First thing you're going to do is find slope. So we're going to do change in y on the top, which is the f of x, the output, change in x on the bottom. 12 minus a -2 divided by, and since I went this way for my subtraction, I need to go that way. 3 minus 5. So what do I get? 14 over -2. Am I right so far? 14 over -2. So my slope is -7. Awesome. So if I were filling in a formula, or a linear function, right now I know, and this is an f, f of x equals -7, because that's my slope, x plus b, right? This is what I know so far. But clearly that is not going to be enough to create a usable function. I need to somehow solve for b. Here's how. Plug in an easy pair of points and your slope value, and then solve for B. And it's going to look like this. I'm going to choose the easier pair of points, which to me is 5 and -2, and plug those in to the appropriate spots. So -2, that's the output, is equal to, slope is -7, x is 5, added to B. You see that so far? Now at this stage of the game, it's not nearly as difficult. Oof, sorry, my stomach's growling. It's not nearly as difficult to visualize how to solve it from there. Solving for B simply means taking this -35 and adding it to both sides. And you should have gotten B is equal to a +33, right? Yeah. So I've got an N value, and I've got a B value. All you need is an M and a B value to create a linear equation. That's all you need, or linear function. So f of x, based on the data I've been given, is equivalent to -7 is my slope multiplied by whatever x value I use, added to 33. There's your answer. And whether they call it functions or linear equations, you can use this same process to uncover linear equations or linear functions, as long as you either have points, slope, y-intercept. Remember, B is what's called your y-intercept. As long as you have some of that data, you can use this process to extrapolate. And we did do this already back in a couple lessons ago, but you guys might not have recognized it. What date? When did we do that? 3.3 or 3.4? We did this in lesson 3.4. Okay, we kind of worked on this a little bit in lesson 3.3 and lesson 3.4. All right, so I'm going to keep going. If I have two pairs of points, find the slope, pick an easy pair of points, solve for B using what you got. Put it all together, okay? What if you're given perhaps some different data? Maybe you're given some different data, and the one I'm about to give you is actually a little bit easier. Same kind of process, same question though. If I give you some data, find me a linear function. This is going to be a G function. And I'm going to give you the following information. Shoot, lost my place. 1. Nice easy ones. The result of putting in a 0 is 3. The result of putting in a 4 is 1. Make it look like X and Y. 0, 3, 4, 1. Now you do have a pair of points. I'm not denying that. But you've been given actually an additional piece of information here, even though it doesn't look like it. Whenever X is 0, the other number, the Y value, is the B value. Okay, I'm going to write that down. If X is 0, then the Y is the y-intercept, also known as B in G of X. Since this is a G, is mx plus B. So I already have my B value. Already have it. Kind of convenient. So instead of needing to solve for my b value like we did in the previous one, I actually already have it. So all I need to uncover is my slope. Change in y over change in x. 3 minus 1, 0 minus 4. So what do we get? 2 over negative 4, otherwise known as negative 1/2. So can I plug this in right there and have a nice handy dandy g function? Sure I can. G of x is equal to, plug in the slope. You already had your y-intercept and you're done. All you had to do for this one is get your slope. Be on the lookout for these. Go ahead. Well, if x is 0, the y value is the y-intercept.
So like always?
Yes. If x is 0, then y is the then the y value is also the y-intercept in all cases. Good question. I mean, I think Ashley just realized the awesomeness of that little development because that gives you already a huge thing. I mean, it's almost like if I said to you, write me a g of x function with the following data. Slope is negative 1/2. Y-intercept is 3. If I was that obvious, you would already have the key components you need to plug in your M and your B. But in this case, they gave you this, but in a sneaky way. They gave it to you as part of one of your pairs of points. Okay? Sneaky. Okay. I want to practice several more just like this with you using your textbook, starting on page 149. And I want to do a handful of odds with you. Okay? I know you guys don't want me to take too much more of your time, but I feel you definitely need to practice this with me before it'll start to feel good. Example 1. Find an equation of the linear function f using the given information. And this is an example of easy. If they tell you m is 2 and they tell you b is 3, then what will your f of x function be using that data? F of x equals, what do you think, Ben? 2x plus 3. Very good. Plug in your m, plug in your b. Number 3, on the other hand, do they do the same thing in a sneaky way? I think they do. M is 3, and they give you a pair of points. If x is 0, then the y value is the b value. In other words, based on this information, I know that b is 1. F of x is equal to 3x added to 1. Because I know that the x value at 0 produces your y-intercept, I can plug that in there, plug that in there. Okay, a couple of freebies for you. Number 5, what do you think of number 5? Still at the bottom of page 149. It might be written a little differently. Same thing, Ashley, very good. Same thing. Negative 2 is your b value. 1/2 is your slope. Take a look at number 7. A half of a step harder, but not by much. Here's number 7. They give you your b value right up front. f of 0 is 1, so I know b is 1. And then they describe to you the slope. They don't give it to you, but they tell you that it increases by 6, which means that's a y value, up, down, when x increases by 3. That's your x value. Yep. So if they say to you f of x increases by 6, that's your numerator. When your x value increases by 3. What they've already done is they've taken the points, whatever the points are, and given you the result without reducing it to what m is. F of x equals 2x plus 1. Those are some easy ones. 9. How can I work number 9? I'll give you guys a second to look at it. They've already given me my slope, and they give me a single point set. There's my little skeletal version of y equals mx plus b. What can I do with these points in the skeleton of y equals mx plus b? What can I do with this 5? Go ahead. Plug it in. That's my y value, you bet. And I could plug in my x value as well. And solve for b. B equals 3, do you agree? I've got my recipe. F of x. They want it written in function notation, so you have to write it in function notation. F of x, g of x, whatever they tell you. Give an equation of function f. If they say that, you have to use f of x. This would be wrong. Even if that was a choice on your ACT, you have to choose this one. Okay? I like all these little hints I'm throwing at you. My college-bound kids. Can't believe it. Okay, my friends. Let's go to number 17. Find a linear function with the following data. Here we go. I don't have a slope. I don't have a sneaky b value because I don't have any x's that are zeros, do I? So I'm going to have to go back to where I started in the beginning of this lesson, solve for slope, step 1. So m is equal to, let's go this way, 5 minus 2 and 2 minus 1. Looks like m's value is 3. Would you agree? Bueller? Anybody? All right. Now that I have this, Dylan, what can I do with it? Plug it in and solve for b. Plug in m. Use the easiest pair of points. Solve for b. I'm going to use my 1 and my 2. 1, 2. B is -1. F of x equals 3x minus 1. You see why it was so important to me for practice? You guys see why? This is not something that you can just go, oh wait, yeah, I get it. If you don't do it, you won't get it.